All right, in college algebra, in section 2.2, we're going to be learning how to work with these equations for circles. This is the center radius form, where it's x minus the x corner of the center squared plus y minus the y corner of the center squared equals r squared. General form, you will expand those out and also move this r squared over. It has to be set equal to 0. That's probably one of the biggest mistakes I'll see students make, is they don't set it equal to 0 when they type this in onto their homework and test. All right, so find the center radius form and the general form of an equation for each circle described. So we're given the center, so that means this is h and this is k, and I'm given the radius of 3. So we will literally just plug in for each of those for the first part. So since my h was 1, it's going to be x minus 1 quantity squared, y minus negative 2, so that one right there will become y plus 2 quantity squared, equals the radius squared, and that's where I got 9. Now for general form, you will either need to FOIL out or box out this first term, okay, because it's a binomial squared. You also have another binomial squared. Some of you don't do FOIL or boxes. Some of you are trying to do the shortcut. So the shortcut would be x squared, multiply the 2, negative 1x, doubled. The last one squared, plus 1. This one squared, multiply the 2, that's 2y, doubled is 4y. 2 squared is 4, but it was still equal to 9. Now, to put it in general form, notice it goes the x squared term, y squared, x, y, constant equals 0. So I do need to combine this 1 plus this 4, which would be 5, but I need to minus the 9 over to the left side. So 5 minus 9 is going to give me this negative 4 right here. All right, so again, that's the general form. So center radius form, you can quickly tell me the center and the radius. General form, we're going to be going from this back to that here in a little bit, and we'll talk about how to do that. All right, so if my center was 0, 0 with a radius of 2, well, again, my h and k are each 0, so x minus 0 would still be x, and that would give me just x squared then. And y minus 0 would be just y, so therefore y squared equals the radius squared. Now to put that in general form, again, I don't have anything to expand out, so I just have to move this 4 over, make it equal to 0, and that would be my general form. So what if they asked me to graph it? See, when I'm looking at this equation right now, this is in point, this is where you know the center, it's center radius form. So the opposite of that, so positive 1, opposite of that, negative 2 is for my center, with a radius of the square root of 9, which is 3. Now, when you guys plot this in the system, you will go ahead, click on the graph. You're going to go pick up the circle. The first thing you'll do is go plot the center. So you will go to 1, negative 2, and push enter. At this point, please use your arrow keys. Don't try to do it with the mouse because you might be off a little bit. So use the arrow keys and either go right, left, up, or down 3 units. Don't try to go diagonal. Make sure you go either vertical or horizontal. 3 units, hit enter, and then that will be your circle. All right, so if this was my equation, x squared plus y squared equals 4. So again, we need to remember that x minus 0 would still be just x, and then it's squared. So therefore, this center is at 0, 0, with the radius of the square root of 4, which is 2. And again, I just discussed with you on how to do that. Again, don't do a radius diagonal. Please make sure you do your radius of 2, either right, left, up, or down. Do not try to do it a diagonal. So what if my equation is already in this form and I need to go back to the center and the radius? Well, we did completing the square in chapter 1 to help us with the circles and finding the centers and the radius. So we'd want to make sure that we do our completing the square. So I want x squared plus 4x plus the blank. I want the y squared with the y term plus a blank. Equals, notice I had to move the 44 over. So that's why that's positive 44 plus a blank and a blank. Now, when we completed the square, we talked about that in chapter 1. We're making it to be a perfect square. So to do that, remember we would cut this in half and we would square it. So half of 4 is 2, squared is 4. So I'm going to add 4 into that blank. Half of negative 8 would be negative 4, but squared is 16. So plus 16 went here. And if I add it to the left side, to keep this equation balanced, if I only add to the left, it's not going to be balanced anymore. So I want to make sure I add to both sides to keep it equal. So if I add 4 on the left, I've got to add 4 on the right of the equal sign. Same with the 16. Now, we made this a perfect square such that that variable, half of plus 4 is plus 2, quantity squared. Y minus 8 squared plus 16, there's the y. half of the minus 8 minus 4, quantity squared, equals 64. So my center is negative 2, positive 4, with a radius of the square root of 64, which happens to be 8. So this next example, I want you to notice we have something in front of our x squareds and y squareds. When we talked in chapter 1, we talked about only wanting to do complete in the square when we had a coefficient of 1 and evens. Well, we may have to do complete in the square where the coefficient is 1 and these might not be even, and we'll talk about that in a minute. So the first step I am going to want to do, sorry about this, I'm going to have to move this book. Okay, so the first thing I need to do is I am going to want to make these be a 1. Okay, so I can complete my square. So let's go back to the problem we're currently on. So to turn those coefficients for x squared and y squared into a 1, I would divide every single term by 2. Even the 45 gets divided by 2, every single one of them. So that's now x squared. That divided by 2 is 1x, and I know I'm going to need a blank. That becomes y squared. Dividing that by 2 is negative 3y, and a blank. And 45 divided by 2, plus blank and blank. And you'd be welcome to use decimals here if you want to. The computer system did not say you had to use fractions. All right, so to complete my square, I want to take a half of 1 and then square that. See, if I take a half of 1, that would be 1/2. 1/2 squared means a half times a half, which is 1 over 4. Now for this one, I want to take a half of that negative 3. So a half of negative 3 would be negative 3/2. Square that, that means negative 3 over 2 times negative 3 over 2. See, negative 3 times negative 3 would be a positive 9, and 2 times 2 would be 4. So that's where we got these numbers. So again, it's half of that squared. Half of the negative 3 squared. Now, y'all, we need to factor this left side. So this will be x plus, because that's a plus sign, half of 1. So it's going to be x plus 1/2 in quantity squared. Over here, we're going to have the y, and again, half of the minus 3, so that would be a minus 3/2 quantity squared. Now, how did I get this number? See, if you had used the decimals, it would actually be fairly easy. You would just go ahead and add them up. But if you use the fractions, you'll have to get a common denominator. So that denominator here would be 4. So to make this turn into a 4, I'd have to times the top by 2 and the bottom. So that would be 90 over 4 plus 1 over 4. So that's 91/4 plus 9. That's 100 divided by 4, which is 25. So my center is going to be negative 1/2. Positive 3/2. The radius is the square root of 25, which is 5. So this one wants us to find the center radius form of a circle having these two endpoints as a diameter. All right. So remember the midpoint would be of the diameter would be that center. And instead of memorizing formulas, I like for you to understand that midpoint is like the average of the x's and the average of the y's. So I want to average the two x values together. So 7 plus negative 9, that's negative 2, divided by 2 gives me an x coordinate for my center of negative 1. Then I want the average of the y value, so that would be 2, plus the 8, that's 10, divided by 2 gives me 5 for the y coordinate of my center. Now remember, that's my center for my circle. That's my h and my k. I also need the radius. So I do not plot the endpoints. I am plotting the center, negative 1, 5, and one of the endpoints, I just went ahead and chose the 7, 2. Now remember, that's the center of the circle. This is an endpoint of a diameter. See, so the circle really looks like this right here. Now I want the radius. That means the distance from here to here. So many of you try to memorize the distance formula and then you don't recall it when you take the SAT exam or ACT. So I'd rather you understand how to do it instead of the formula. So what we'll do is we're going to drop a vertical distance and a horizontal distance. Remember, we're talking distance between 2 points. So if I drop a vertical and a horizontal, well, I could do Pythagorean theorem then. So now all I need is the distance between these x's. From negative 1 to 7, that is a distance of 8. For the distance between the y values, from positive 2 to positive 5, that would be a distance of 3. Now I just need to do Pythagorean theorem. So 8 squared plus 3 squared equals c squared. So 64 plus 9. And therefore my radius is the square root of 73. And I'm ready to plug into my formula. So remember, the formula was x minus the x coordinate of the center. So x minus negative 1, quantity squared. y minus the y-coordinate of the center, so y minus the 5 quantity squared, equals your radius squared. If you did this distance formula with the 2 endpoints, remember that will give you the diameter, not a radius. And our formula talks about radius squared, not the diameter squared. That ends our notes for 2.2. The lesson is pretty short, so I wish you guys the best of luck on it. Have a great day.